Hello, everybody. So it's going to be kind of a short week, just tonight, and then the Thanksgiving break starts on Wednesday, so no school on Wednesday. Yeah, so we got to go over tonight. Oh, I entered the list. And yeah, the list I wrote down is, I'm not sure how far we'll get, because the first thing we're going to look at tonight is something I like to cover. This class is Introduction to Software Development. Doesn't say anything about Python in the name. So I like to throw in other languages and also to explicitly demonstrate that point of the reason we've been studying Python so slowly, and stretching like selection structures out over the whole week, is so that we understand how they work, so then we can go to other programming languages and learn them very, very quickly. So we're going to do our first pass at one of those tonight. I'm planning 3 by the end of the semester. Probably also like to later in the semester maybe do VBA. That's the small scripting language that we would use in like Microsoft Office, Word, or Excel. There's Alt F11, and then you can code up a new button if there's not a button in Word or Excel or PowerPoint that does what you want it to do. That's a useful language to look at. So that's one that ranks pretty high on the list of the things we might cover. After we go over that, I want to do a quick pass at exception handling. Not sure. I didn't see it in the book. I don't remember seeing it in this textbook, but I tend to look at lots of textbooks and sometimes they run together. I didn't get a chance to go back and look. I don't remember seeing exception handling, so I at least want to go over the basics. Because there's different levels of errors, right? Some errors are major issues we can't do anything about. But some of those errors that crash our program are just little hiccups that we should be able to work around. So that's exception handling. We'll talk about that this evening very quickly. And then after that, the next module is listed as starting GUIs, which is event-driven programming. So, and depending on where the time is at that point, then we might get started into event-driven programming. That's why I sent those example files out today for those who saw it in the announcement. So we might get it here. So instead of waiting to class and sending them out, I'll just go ahead and send them out now, because those are example files I've had for a couple semesters. The reason there's 2 of them, those GUIs do the exact same thing. It's just one of them is written with the class notation, where we create a blueprint for object-oriented programming, and the other one is in Python modular notation, which on all technicalities is an object. We talked about that last week very briefly. We kind of treat them differently, but the previous class had seen the object-oriented stuff before we got to GUIs. So that's what the reason I went ahead and sent both out. In that particular example, and then the other ones we'll see when we get to it, the class notation offers us no advantage. But then other situations, that class notation offers us a lot of advantages. So we'll talk about that soon, because we're going to spend a couple weeks on that. Right? That's not a trivial thing. When we say the word software in modern America, we don't think about things running in the console, right? That's not what springs to mind. Personally, I would have started the class with GUIs, but I feel I need to be consistent with the way Ivy Tech is trot across the state. And for the statewide version, it doesn't show up until much later. But we'll get started into that tonight, and we're going to spend a couple weeks on it, because that's kind of an important thing, right? We don't want to build software for a console. We want to build software that people can click on buttons and do all the stuff they're familiar with, right? When you download a new piece of software, if you've never seen it before, you probably have some guesses of where to start. Probably know that if you go to the file menu, whether it's stretched out across the top in the traditional style or nestled up under a hamburger button, you can expand that button and get to a button that creates a new file for that software. Sort of a standard place to put it. It's not an IEEE standard, it's just the way that everybody does it, so you find it. Talk about things like that. That's what we want to do with our software. So we're gonna spend a couple weeks on that and probably get to it tonight. Because the point of the first thing on the list is that looking at another language, and one I always like to include because it's a very, very useful language. One of the things that we're gonna talk about is PowerShell, which is the Windows operating system control language, the thing that replaced the old command prompt. But there's even more advantages to it than that. We will get to very, very quickly. I only had two quick announcements that I wanted to make. There's a couple women in this class, and you all are well aware, you probably heard about the issues, women in the STEM fields, science, technology, engineering, and mathematics. The ratio is very out of proportion for what it should be, right? With humans, there's roughly an even match of men to women in society, but something's wrong with the ratio in STEM fields. Like picture a stadium, a good college-sized basketball stadium, holds a lot of people. A college basketball stadium filled with people, and now imagine if only one of those people was a woman. Like that's how disparate the ratio is. So we want to do things about that. I sent out an email earlier mentioning money that was available. Kenyatta, who is the chair for the cybersecurity department here, I think he's also the chair for the server admin department. I was talking to him the other day, and he's looking into sponsoring a women in STEM club. If anybody's interested in that, clubs look good on the resume, and if the club is explicitly women in STEM, and you're applying for a science, or in our case, technology, some sort of engineering or mathematics thing, that's going to look really, really good on the resume. So, club to keep in mind. If you don't have him in any classes and are interested in that club, I can match on his contact info for you. The other announcement I wanted to make, I'll share the screen here. At this point in the semester, everybody's getting a little exhausted, right? It's pretty common. School can be overwhelming, tiring, start to get really, it adds up. And that's not an unknown fact. If you're feeling overwhelmed and super anxious for the break, you're not alone. School can be overwhelming. And the school here is, like all schools, is well aware of that. So one of the things that is available here at Ivy Tech is there is a counselor here at the school. If you're feeling overwhelmed, need somebody to talk to, there is a professional therapist on staff here. I think she's actually connected to Heart to Heart, and it's an office here. For those who aren't local to the southern Indiana region, to one of the local mental health places. So if you're in Indianapolis or up in South Bend campus, there should be a therapist there on staff as well. Because school can be overwhelming. It's a well-known fact. So if you need somebody to talk to, the way to contact her is in our syllabus. Excuse me. Over in the syllabus, in the Ivy Cares program. She's part of the Ivy Cares program. So if you contact Sellersburg-Ivy Cares, or for those at some of the other campuses, I'm pretty sure the email address would be like Indianapolis-Ivy Cares, or South Bend-Ivy Cares, or Fort Wayne-Ivy Cares, or Kokomo-Ivy Cares. Whichever campus you're on, it should be an easily predictable link to adjust it, or the one in our syllabus, they will know the link for sure, so you can just contact them and ask them what the email address is for whichever campus. But as we come in near the end of the semester, everybody's probably feeling overwhelmed and exhausted. That's very common. So most schools do keep counselors and therapists around. And she's a professional therapist, so any privacy issues are like it would be anywhere else in that field. You don't have to worry about her running back to anybody else's and sharing things. It's the standard for, I guess, psychiatry society, American Psychological Society. Oh wait, no, it's APA. Same people that do the formatting rules. Is it American Psychological Association? Whatever APA stands for, it's the rules of privacy. She's a professional therapist. Just in case anybody needs that, because it can be a little overwhelming at times, that's for sure. So coming up after tonight is pretty much a week off. You have Tuesday classes, you might still have something to do, but otherwise, we won't meet again until next Monday. It's time to jump into our topic. Oh, there's Madeline. I'll let her in, and then we'll get started. As soon as her mic kicks on. Hello, Madeline. There were a couple of announcements we just finished that might apply to you. Kenya is looking to, one of the faculty members here at the School of IT is looking to start or sponsor a Women in STEM club. That's something that would look great on resumes. Clubs always look good on resumes, and women in STEM is kind of a big issue. So if that's a club that's on your resume, it'll look good. And also, I was just telling right before you logged on, just passed on the reminder that on our syllabus is a link for Ivy Cares, and that includes a counselor on staff here at school, because school can be overwhelming at times. And periodically, it's good to have somebody to talk to. Just thought I'd share those. We're just getting ready to get started here. So first up tonight is kind of covering another language. This course is called, oh, before we get started, does anybody have any questions? I assume silence means no. So this course is called Intro to Software Development, right? It doesn't have Python anywhere in the name. So one of the things I want to do is look at some other languages. And first off is one that I think will be very useful for you. I'll go ahead and bring my laptop in here. Which actually you've seen me use it before here in class. Don't need audio on this one. You've seen me use it before because since everybody in here is using different IDEs, actually there's kind of a selection of just 2 or 3, not a whole lot of different ones, but there's different ones. So I've been doing the class examples in just a plain old text file and launching them from the command prompt or PowerShell mostly. So way back in the 1970s, early 80s, when things like command prompt for what eventually became Windows machines, or bash terminals on Unix machines, which there's not much Unix left anymore. Command prompt bash terminals, when those were created, RAM was a very precious commodity. Right? Those machines, RAM was measured in kilobytes on the really, really good ones. We didn't have much memory to work with, and we certainly didn't want to waste it on the computer experts. Right? The users needed that memory, so we saved it from computer experts by everything was abbreviated. Anybody that's worked on those knows all our commands are abbreviations. So we have to memorize those in order to work with it. Just a list of blank memorization things. And it's somebody else's abbreviation, so a lot of times it might not be the way we would have abbreviated, which makes it even harder to memorize that list. And there's a lot of non-intuitive things in place that are more efficient for machines, but it's for a machine. It's not intuitive to humans. And these made it harder for those to use. Not bad. You get used to it very, very quickly. We're humans. We're very adaptive, right? We get used to that stuff, but it could have been easier. And fast forward 20 plus years, and that's no longer an issue anymore. Right? By the 1990s, RAM chips had gotten huge. We certainly didn't worry about conserving them by then. And not only that, CPUs had gotten much faster and more powerful. So CPUs had ample speed for both the programmers and the users. We didn't have to try to cut things out on the programmer side so that the user, it wouldn't go slower for the user. There's plenty of speed along the way. And while all that was happening on hardware, a lot more people learned to program. There was a lot more people pick up software development or basically just learn to program in general. Because during that time, home computers became a thing. When that stuff was originally created, a computer was sort of a precious thing itself, not just the components inside of it. But by the 90s, more homes had computers than didn't. So a lot of people had learned about computers by then. And programming in particular, some things had started to stand out as just kind of being easier for humans in general. Things that you're familiar with now, because we've seen them in the Python programming language. By the time that was developed and kind of put in place, there was a lot of that trial and error of different symbols where there was complete freedom across a number of languages. As more and more programmers added, we got to the syntax like we're used to. Some consistencies across the languages. Things that are consistent. So those old abbreviations and non-intuitive ways weren't really necessary anymore for the operating system control language. Windows was the first to upgrade theirs around 2006. The operating system control language. That name of it's very important. It tells you what it is. Windows, like what you're used to. I share my screen here. All these pictures here, things to click on. This little GUI here was written in PowerShell. Stuff down the taskbar, stuff to click on. Yeah, mostly that. The buttons, the nice organized text fields to type into. Those are just images. The control system language, the operating system control language is really what Windows is. So when I say we're going to pass a PowerShell as a scripting language, that's what the real Windows. All of these pictures that we can click on with our mouse are just pre-built shortcuts to things built with that operating system control language. And obviously some of those things, we don't want the average user to have access to. So when we actually know the language, we can do a lot more than we can do things that are completely blocked from the graphical user interface aspect, because it's things that we want to restrict that only computer experts have access to. So that's why I like to cover this one. It's a very useful language for Windows machines. The basic idea is, well, change on those points I mentioned a moment ago. There's no need to remember what you want to do and how someone else abbreviated it. Things are spelled out. And they're spelled out with a very simple naming pattern, which hopefully you'll see the pattern before we get very far into it. Spelled out using a simple name building pattern. And it included a full scripting language that wasn't, or that matched some of the most popular languages. So by that time, some languages really stood out as being more popular than others. So when they wanted to upgrade that and make it easier to use, they looked at some popular ones. The three in particular, they took parts from even other languages, but the three main ones, they looked at JavaScript, Python, and PHP. We've been looking at Python, so one of the languages this is modeled after is the one we've spent the last 5 weeks looking at. So it should come very quickly to write scripts, as opposed to the old way, if anybody's done that, where you have type symbols all over the place and our loops look really strange. So make some notes here. I just have a marker. Oh, here it is. PowerShell. It's modeled after JavaScript, Python, and PHP for the most part. So it's loosely typed. Like PHP. PHP is a version of C++ that they took out all the type requirements and made it an interpreted language instead of a compiled language. A lot of y'all probably see that it's a very popular language. It has line breaks.
Hey, Chris.
End of instruction. What was that?
Sorry. You're still sharing your screen, which makes your video real small. We have the ability to change it, but pinning it does, like, yeah, there we go. It defaults to you being real small.
Yes, thank you. I just forgot to click the button. I did mean to. Anytime that happens, please remind me like that. Let's see where, oh yeah. So loosely typed like PHP, which that was a question on a quiz earlier this term. Python is open type, and one of those questions used the word loosely typed instead of open type. We'll talk about what loosely typed is here in just a few moments. Has line breaks for the end of instruction symbol, like Python. So that one's really nice. It fits human intuition. When we get to the end of the instruction, we hit enter, go to the next line, and that's our next instruction. So follows that. But Python went a little bit further with the white space. And at this point, has anybody encountered a message that says indentation error? I see head nods here in the class.
Oh, yeah.
Yeah. When the white space is wrong, and then you have to dig through all your code looking for the missing white space or the extra white space. It makes semicolons seem really, really nice. And curly braces. So that's the thing, third thing on the list here. It has curly braces. Has the curly braces to define blocks of code. Like JavaScript. For those who have used JavaScript before, it kind of has this. We mostly still use semicolons for end of instruction because JavaScript will run quicker with a semicolon. So we usually still use those, but the curly braces mark out blocks. So then our indentation is only for our own readability purposes. It's only to make it easier for ourselves. We don't have indentation errors like we have in Python. So that's kind of the idea of the syntax, main syntax we use. But it wasn't just new stuff. They kept the old stuff. We'll see this a couple of things along the way. They kept the old stuff. They just added to it. And not just this stuff. As some of us, Justin's probably on this list, we end up in IT positions where we have to work with different systems, right? If you're an IT guy, there's a good chance somebody's going to call you about help with need your help with a Windows computer. Somebody else is going to need your help with a Mac, or somebody else is going to need your help with some custom version of Linux they put together. And there's different systems. And that gets very, very confusing when we have to jump back and forth between those bash instructions and the command prompt instructions in order to troubleshoot things. So some of the most common ones from Linux were added in as well. So they didn't just keep the old command prompt instructions, they kept some of the old bash instructions to make it easier jumping between systems. We also have the ability to rename things. We can give things our own names. Like we can rename the instructions ourselves if we want to. helps clear up confusion, because you may have seen me do that on PowerShell at some point. You kind of mix between the Linux and the Windows instructions, and both of them run in PowerShell. Obviously, independent programmers were kind of quick to jump on this. There are a lot of programmers in the world these days, and they like to solve problems. Windows had this nice updated thing to run for an operating system control language. So a lot of independent programmers were really quick to make translators, little pieces of software that would translate that and feed it right into a bash shell, or feed it directly into your bash script. So it didn't even have to be written out in the shell, in a text file. And then it would work for multiple systems. And Microsoft was like, hey, that's really nice. And in August of 2016, they went with that. They picked their favorite, which really means, I think it was a little more pick and choose between the favorites, and put together a new one that had the best of some of those. And in August 2016, they officially made PowerShell open source across platform. So it's not just a Windows thing anymore. It is all of our systems. So one language for operating system control for all of your operating systems. So there are definitely some good reasons to use it, to know it. Like I was saying a moment ago, essentially the operating system control language for Windows is Windows. That's what Windows really is. The pictures that we click on are just shortcuts to pre-built things using that language. So let's start taking a look. Obviously, we won't see the whole thing. And this is also supposed to be an explicit example of why we've spent so much time studying this stuff in Python, to see that the logic and things we've been doing apply elsewhere. All we need to see is the new syntax. So I'm gonna go and share my screen and open PowerShell. I have one other thing to write on the board, so I will try. I should remember, since it's only been a couple minutes, to stop sharing my screen, but please let me know immediately if I forget to. So there's two things we're going to look at. If you just go to the Start menu in Windows and start searching for PowerShell, you'll see the regular PowerShell. I'm going to go to that first, but you'll also see PowerShell Ise. That's an integrated shell environment. We'll look at that. So basically, it's the same thing as your IDE. This language kind of has a different purpose, so we don't call it development. More of a lifetime thing. I keep it shortcutted to my taskbar, so to open it, I'm just going to hit Windows 2, the second thing on my taskbar, and zoom in a little. Oops, not Control plus. Everybody see that okay? I need to zoom in a little more.
That's big enough.
Okay. So that first part should look like the old command prompt. Windows X, I'll open that real quick. The old style one, built originally back in the late 70s, early 80s, no colors, just text, which that's another thing. I probably should have included in the example tonight. A common example that most people are aware of is pinging another machine. Right? We just check our connection by pinging it. If we do that the old style way, we get back text telling us something. But if we ping another machine from PowerShell, we get something better. We get an actual object that we can immediately work with in our scripts. We haven't got to object-oriented programming yet, but we get back an object. So, like I was saying, all our old commands still work. CD, which in Windows was current directory, on Bash was change directory, so that one kind of worked on both systems. But change directory, and we can go into the documents /delete folder. And I go the normal working place. And once we're here, we can pull up the listing using the old command for Windows. That was dir for directory, and see the stuff that's in there. Well, this would be a great one. I didn't realize that was still in there. So, yeah, I'll use a Linux command. Is it REM or REM? I think it's REM. We can remove stuff out of this picture here, and that particular screenshot happens to have some information that would be further protected on it, so I better remove that immediately. Just grab it, copy, and paste that in there. Now, if I pull up the listing, I'll use ls, the Linux command for those who are familiar with more. And you can see that advantage right there. It doesn't have all our Linux commands, but a lot of the common ones are there. The most common ones are there. Make directory was the same on every system. So obviously that's the same. CD was the same. But if you have them like dir and ls, it kept the old commands, they still work. Clear is an old command. We'll see the new version here very, very shortly. So I'm going to change directory, then ... is still the standard symbol for go back up. I'll go back to the starting point. So clear is actually the old command, it still works. Clear host, our window, our shell here where we're running this is referred to as the host. So it's part of that name building pattern. So clear host is the new command. So the names are built up of a handful of keywords. Set and get, those are the two we're going to use most often, obviously, and it should make sense. So if you want to set something, you're changing the value of it. If you want to get something, you're retrieving the value of it, you're asking for the value of it. So like a variable, we want to set the value of a variable, means we're going to change it. Or get the value of a variable means we want to use the value that's stored in that variable. Which actually, that's a very, very common thing. We call them setters and getters, methods built into our objects to either change the value of a variable or retrieve the value of a variable. That's what everybody calls them, the getters and setters. Even most of your IDEs, when you hit Control Insert or Alt Insert, whichever one it is on your IDE, and it goes to insert things, the option on the menu is going to say insert getters and setters. So if you see it in a multiple choice question in a classroom, the actual answer is mutators and accessors. Mutate for change it, and access for retrieve it. But that's only a multiple choice or certification exams or something. But a couple keywords like that, set and get, new, we build up some stuff. So it's set, then dash, and then the thing we want to do. So the new version of changing directory, we call that, a better word for that is location. Right? Directory is sounds so formal. Directory refers specifically to folders, and intuitively, that's not how humans talk about them, right? We talk about our location in the computer. Where are we at in that hierarchy of folders? So that's the word they went with, the one that kind of seemed more intuitive. So set location is the new version of change. And that's the first part of the name building pattern. We want to change our location, so we're going to set the value of location to something else. If you have spaces in the names, you do have to have it in quote marks, so I'll do that this time. I'll even put the other slash. I'll go back to my delete folder and use the wrong slash for a Windows system. / on Linux and Mac, and / on Windows. But it'll run fine with it. It'll accept both of them. And if you have spaces, you have to have quote marks. If you don't have spaces in your names, you can leave off the quote marks. And get location is kind of asking for it. So you can That's the first glance at the name building pattern. Location is the thing we're worried about. And then we add one of those key words in front of it. So set dash location and get dash location. Excuse me. And then this thing that it sent back, is not just text. The old command prompt would have just given us back a string for that. I'm jumping ahead a little bit here, but I'm gonna go ahead and store that. So I just put it in this variable called P, and you see it prints out the same thing. There's not really much to it, but I can ask for p.path. It moved that into an object, so that stuff is immediately accessible to another script. It's not a string that we have to parse through and dig out the part we want. That's a useful one. Clear host. This window is called the host, so we can do the same thing with our host. We'll get to variables here very shortly, but I'm just gonna go ahead and put this somewhere. So ignore the left-hand side of the assignment here. But that is assigned get host instead of clear dash host. The simple building pattern and the thing we want to work with, we choose another word from that building pattern, our get host. So now if we print that out, we can see a bunch of stuff about it. But it's not text. It didn't send us back a string. It sent us back an object, so we can access parts of that. So like that place where we stored it, .ui. Basically shows us what's on the screen there, only a little bit more. It's calling from system management, automation, internal host user interface is the raw UI, but when we accessed it explicitly, we also saw that we can run virtual terminals from this one. So you do your SSH. You don't need anything special to do SSH. Just tell it what IP address you want to connect to, like a bash script. That's one big change over this. Bash has always had that functionality. Windows did not have that functionality in the past. So just run your SSH stuff and give it the IP address for your AWS server. Almost all AWS and moving even more that way. So soon it will be all AWS, it seems like. And yeah, I guess basically that means you don't have to install PuTTY on your Windows machine. You can do it right from PowerShell. SSH is built in. Or other things on that list. For example, we could say that place where I stored it, private data. That's a good one. Oh, there's some data about this stuff. Error foreground color, error background color. Probably have a good guess on what all those things do, right? And we can access them. Let me put a typo. So instead of write, I'm going to put Rick. Hello world. A quick typo, we get an error message. We can see that black in the background, and from our private data, we can see error background color is black. So we can reassign that. H dot, that was under private data. And it is still Windows, it is not case sensitive. In fact, that all lowercase, all uppercase. I'll type it all lowercase to express that point. And then that private data had all of this stuff, including error, background color, which I just did this, it would print it out, but I could assign that another value. Those values are strings. The colors, they're not variables passed in there. So if I say make that yellow, and then run that command with a typo again, see we have correctly access that stuff and control it. Shouldn't be any surprises there. Clear host. So the host is the name of the thing there. We can access that stuff. That was kind of jumping ahead. Let's see. I guess now that was preview, just looking at stuff. So now into the stuff that we've studied in Python. I'm gonna do it in a different order. So operating system control language, so we probably think about things differently, right? With our operating system, first thing we're probably thinking about is making folders and sticking files in. So let's do that first. We're here in this directory. I'll pull up the directory listing. See, there's folder game resources and GUI reference stuff. That's the folder I sent out earlier. We're going to spend a couple weeks on that stuff. I think we'll probably get to it tonight. If not tonight, we'll get to that next Monday after the break. So if I want to make a new folder, the old command make mkdir make directory, that was the same on Windows or Linux, so obviously that one still works. The new one, things are referred to as items. That's the intuitive term they went with. The stuff we have, our folders and our files are items. So when we want to work with them, well, we have those same keywords to build up our instructions. The new, or set and get, and third one here is new. We want a new item, and we need some other stuff. And this was the part I was going to write on the board. There is help built in here. And actually, after we go through it here, which I'm expecting to be about 25 minutes from now, we'll look at a better place. We'll look at that IDE for doing this, which is much more useful. So get help on new item, and we'll look at this. So if you look at that for a moment, looks kind of strange. Aliases as the old Windows new item command. NI. We actually spell it out, new item, so that's our instruction. And then here's our parameters that we can pass in. So new item is a function or a method. We use those words interchangeably. This one does fit the definition of function. It stands alone. It's not part of something else. And how we read these parameters, I want to write this on the board. So stop the screen share. Yep, I remember this time. Where's the good marker? Here we go. So this you might have saw there before I stopped sharing the screen, there's a couple different symbols going on. And it looks like we mix and match them. So how we read those is it will have our command just written out as the word. And then in square brackets, you might see some parameter. And they're set up different. Some of these, immediately after that parameter, it closes the square bracket, and then it's followed by something in an angle bracket. Which is the type of data we pass in for the argument. So that's what the first one here is. If I share my screen again. So the first one here, you see, we have the parameter path, and the square bracket closes, and it's immediately followed by the word string and angle brackets. So that's saying the parameter path needs a string passed into it. And when they're split up like that, the square bracket closes, then we have the stuff in angle brackets. That is a required parameter. There's no default value. We have to fill that one in. Another one way that could be written is you can open the square brackets and have parameter, then do the stuff in angle brackets, which again is still just the type of data we pass in as an argument to fill that, and then close the square brackets. So if the closing square bracket includes the data type, that's an optional argument. So if I share my screen again, you can see the second one fits that. we have the square bracket, says the parameter is item type. And our options here are, when we create a new item at the operating system level, we're either creating a folder or a file, which does take the word directory, the more formal word for it. So our options for item type are either going to be directory or file. And the square brackets mean that's optional. So it'll default to something. Then we could pass in a value for this one. This one looks different though. So we have a parameter in square brackets, but the very next thing is another parameter. So when we have that, those are the Booleans. So if we just have the square brackets listing what parameter we want to work with, that is a Boolean. So omit that parameter for false and include it for true. So that's how we read those help instructions, built right into it. So it makes it a lot easier to learn. So that's part of the reason this pass is going to go so quickly, because we can pull those up immediately and see how to read them now. Yeah, okay, so now, any questions about reading that? It's straightforward once you see how to read it, but if you just approach it blindly, like I did, it took me a minute to get used to figuring out how to read that. But the help stuff is always written that way. So now that we see that, they're on the screen, we can use it and create a new item. So we see if we put them in order, if we put them in the order that they show in the help menu, we don't have to say which one it is because it'll fill them in order. But it's very, very unlikely that we will need all of them. So it's usually a better idea to go ahead and include them. And it is overloaded. Overloaded means there's more than one function that does the same thing. And the computer will figure out which one we want based on how we send the parameter, how we fill the parameters. Yeah, I guess the other one is there's some different things, names are required parameter, but we can send them in send the parameters in, different parameters in, and then we'll figure out which new item we want. I'm going to look at this first one here. So new item function, it requires the path parameter filled with a string. So dash path, that's how we say what parameter is. And then everything is space delimited. So a space, and then the path really means the name, because it will be relative to where we already are. So we're already at this spot. That part is implied in the file path. So we just need that last little bit. I'll just call it testing 1, 2, 3. And as we move on, the next one's item type. What type of thing are we creating? I like to go ahead and include that. Our options are either a directory or a file. It's two things we can create, really. A folder or the stuff to go in the folder. So that gets us a new folder here in this system. Windows E. Pull up the Explorer and kind of see their new folder. Yeah, so there's the new folder we created. So now we can change directory into it. CD works, so you'll probably use CD more often because that's easier to type and an easy one to remember. A lot of those basic commands aren't too difficult to remember. I'm going to go ahead and spell out the set location. And I want to change the location into that testing 1, 2, 3 folder we just made. And see we're in a new spot now. And we can do the same thing to put something in it. actually, let me pull that list back up. Get help on new item. And the third parameter here, a value. So if we create a text file, we could either create an empty text file or go ahead and put some stuff in it. I'm gonna go ahead and put some stuff in it first, and then we'll look at changing the stuff in it, which more like writing a file. So I guess that's different than what we saw in Python. When we opened the file handler would create it if we're writing. If we're reading, obviously the file handler can't create something to read from. But if we're writing it, the file handler will automatically create it. That was a tricky true-false question that I think caught a couple people on the exam. The file handler in Python will create a file to write to, but it can't create something to read from. Because obviously there's some redundancies that almost seem pointless in creating something to read from. Might be better ways to word that. But we have to actually create them if we're here. So a new item, we need the path parameter, I'll call it testfile.txt, and there's a space in there, so I have to have the quote marks because everything's space delimited. Item type is a file this time, and I'll go ahead and put the value in there. So the value, it says object because this is the Windows operating system control language. Anything Windows can do, from anything we're familiar with Windows being able to do, can be done from here. So there's more than lots of things we can put in. This is a text file, so we can put in a string. Anything that it recognizes, we can put into a file. Any type of object that Windows knows about, depending on the file. For us, it's a text file, .txt. We just need some text here. So like here is a text file. And then a new line. You might be familiar, well, from Python, we saw the backslash, the one where the top is towards the left. The backslash is normally our escape sequence in programming languages. But you can see right there on that line we're typing in, the backslash is very important to Windows. Right? That's how directories are supposed to be listed in Windows. So we need a different symbol for our escape sequence, which is the grave accent is the actual name of it. Most people call it the tick mark, the thing on the key with the tilde next to the one, the apostrophe that points the other direction. The technical name of it is grave accent. That's why it's included on keyboards, but most people just call it tick mark. So our escape sequence for like a new line will be tick in to get the line beat. And a second line, tick in, and a third line. So all that stuff is things we've seen before, just a different symbol for our escape sequence. It means the same thing. It's like, oh, we don't want an in here, we want a line feed, which isn't on the keyboard. So escape out of the coding and actually do something else. Or for symbols that the thing would mean, would know. Like if we wanted quotation marks around the word third line or something, we have to escape out of what we're doing to run that other instruction. So you can see it created a text file, length 55. That looks like about the number of characters I put in there. Assume that's what it's counting. The time was created, the mode, little information that we can access and do things with. We can put that in variables. We saw that earlier. Get item. Hopefully you were able to just guess what that command was before I said it. Right, we know it's an item. We want to get the value of it. So that's one of our keywords, get dash item. And then we can access all of that stuff as an object. You can see it's over here in the file. You can open it up and we should see some text in it. yeah, so wrote the text of the file. Nothing too fancy, but that was one of the things we studied in Python in detail about writing sequential files and how to keep track of our data when we need to store it related to a program. It seemed more core here. And the stuff in that file is referred to as content. So we can build up the instruction get content from path, what did I call it? Test file.txt. And we get all that stuff back. Along with get content, let me create another one. New item at test2.txt. Item type of file, and I'll leave the value off. You see it created it a length of 0. So we see there's a get content. So obviously we have that keyword building pattern for our instructions. So we have a set content as well. Set content for the thing we wanted to access, test2 text file. And then we can pass in that value parameter. Things are named consistently too. So that was another one with the old system, is there was a lot of inconsistencies on both bash terminals and Windows command prompt. Parameters that meant the same thing were named different in different functions, because the parameters just kind of named them on a whim. So a lot more thought was put into this, even on different, but the names are consistent. Here are some words for this. Words for this file. And no error message. It doesn't actually give us a confirmation, but we can run the get content on test2.txt and see those words that were put in there. So that's one of the things we saw in Python, writing text files. And oops. Passed in the wrong instruction. So I'll clear that out. And from that week we spent on writing sequential text files, you know what to do with it. So now that you've seen the syntax in PowerShell, you know how to work with that into your scripts. Now some more a typical starting point where we start at. So should I write this on the board? This is a loosely typed language. Yeah, I'll write this on the board. Do I have room to write it on the board? Oh, it's okay if I erase this original part. Everybody get that in the notes a little while ago. The different parts about it. Line breaks at the end, like we're used to in Python.
There went your microphone. We can hear you again.
Okay, yeah. I was hoping it was fixed. IT said they saw something in the VoIP settings voice over IP settings, VoIP, if you want to just call it that. So we're hoping it was fixed, but I'll let them know it's still did that for a couple minutes. Thus far, it's only happened once a night, right? So hopefully we'll be good for the rest of the night now. I'm not sure where that cut off. So y'all saw the text file, right to text file stuff. Right?
Yeah, it cut out just before I said something, so we were.
Oh, okay. I saw when that typed up. So this is a loosely typed language. That showed up on a quiz earlier. So loosely typed is different than open typed. Remember, in an open type language like Python, we didn't have to say what type of data we had, but it still mattered. Right? Once the Python interpreter figured out that that data was an integer, we couldn't just print it to the console because we can't print integers, we can only print strings. Loosely typed is even further. We don't have to worry about it at all. In fact, what loosely typed means is there is only one data type. So we still have strings, integers, things. We can't use them interchangeably. We have to pay attention to what we have, but we don't have to worry about casting it. We don't have to worry about saying what it is. When we write our scripts, all data types are considered equal, essentially. And we usually use the word resource for that. So we only have one type of data. Don't matter if we need to store strings, store integers, store arrays, store objects. This is PowerShell, store credentials, or passwords and encrypted keys and things like that. There is only one data type. And it's a resource when we're talking about it. We use them all the same. So it is a little bit on us that we have to make sure we don't try to do math with a string. Because obviously, even though we're treating our data types as equal, we can't add hello world, and other stuff. The plus symbol is still concatenation, but there is actually better concatenation in loosely typed languages. You'll recognize them because all variables start with a $sign. So basically our keyword to say we have a variable is a key symbol. All our variable names have to start with the $sign. And we see that means you're in a loosely typed language. And we do not have to worry about data types. So, share that screen. So I've already typed it up here a couple times, but let's a little more formally now. $num1. Afterwards, we need to stick with our regular variable naming patterns. I don't want to start with a number. I want to have something descriptive. So try to avoid the one-letter words and all that. All that stuff you're used to, no spaces. It just starts with a $sign. And as we go through the next lecture, as we're using variables, I will not read $num1. I will say num1, just like I was reading another thing. I've worked with loosely typed languages, and I've just ignore the $sign. I know to type it, so it comes right out. But when I talk about it, I probably won't say $sign. But it should change green, change the color green, so you'll notice if your variables don't change the color green, something went wrong. Let's just do a basic one. Num1 is 3. Other number is 4. And then we can do some math with them. So num1 equals, num1 plus $other num. So we can add them, get a set them back. And well, this is the math section. I'm going to go back to X and Y. Those type a lot quicker because that's what we're used to for math anyway. So we have a number. Let's do like math pass and call it X. X is 3 and Y is 4. Then Z is what's next? X minus Y. Then we can print Z out, which happens automatically, but if you need it more explicitly, like here in a moment, we'll switch, after we do the quick coverage here, we'll switch to a text file where we save this stuff. And then you would want to use the words like write is one of our commands, write Z to bring it back, or echo Z. It's a matter of personal preference. We can't use print though. So if I do print Z, I'll get an error message saying my computer is not hooked up to a printer right now. So print is actually goes to the printer. If anybody was following along and types that on your home computer and you have a printer typed up, it might just print out a number. So you have to remember the print does go to a printer, but write or echo sends it back. Clear host. And then our other math, so whoops. X times Y is right like you expect, 12. Division is going to be floating point division. I have a note about that. I don't have a note about it, but I don't see it in my notes. So floating point division, so Y is bigger, so Y divided by X gives us the floating point number. We have modulus. Color Y percent X gives us just the remainder. 1.33333 is 1 and 1 over 3 is what that would look like if you haven't seen that in a moment. But the math like you probably expect, nothing surprising there. I'll go ahead and do variables while we're talking about, or not variables, we're just looking at variables. I'll go ahead and do arrays right now. That should be fresh on your mind. It wasn't too long ago we looked at lists and dictionaries and tuples in Python and studied what to do with them. So if you're doing some scripting here, which is something I was going to recommend after we do this pass, redo some of that logic you've already figured out in the new language. And there are lots and lots of structures we can use for that. So many that it's quite confusing. I went back and forth a couple times. What I decided to go on with is actually an array list and even an abbreviated way to create an array list, just to try to keep this simple for y'all. So if you want a list or array to work with, and remember that technical definition of array required them all to be the same type. So loosely typed, everything in there is kind of the same type. We only have the one type of data. So we'll give it some sort of reference name. And then in curly braces, we can put in a comma separated list, then type the word dot invoke, which is a method, so it needs parentheses afterwards. This will create an array. The easiest way to create an array. Anybody that's worked with the something in the C family before, C family of languages, might recognize that notation. But that's a very short way to get an array. Because if I call up that data, you see we have each one. And use square brackets to access a particular one. 3 is too big, right? So maybe a index 1. So it starts at 0. Index 0, 1, and 2 give us the 3 things. And the reason I decided to go with this is the fundamental array. We can add stuff to it with plus sign. We can use the at plus equals assignment operator, which is really easy, but there's not a good way to remove stuff. So this notation right here, curly braces, some stuff in curly braces, then dot of invoke, and the curly braces can be empty. We can add them later. If we do it that way, it creates an array list, which has built-in methods add and remove. Makes it very easy to keep track. I thought that would be the easiest way to remember. There's lots of, yeah, you can spend an entire semester talking about how many types of ways we can put together lists and arrays and add different data structures in PowerShell. So I thought this one would be easiest. Just that keyword there, stuff in curly braces, dot invoke, and then you have keywords add and remove. So we could add a 7. And now if we print that out, so we have that other one, or arr.remove the 3. And notice it gave us true. So the return value on remove, when we add it, it just runs. But when we go to remove something, we get true or false back. Because if I tried to remove something that's not there, like if I go type remove 3 again, there's not a 3, so it returns false. So that stuff goes nicely in an if else structure. That way you can be certain you remove the item you intended to. And it is the item, it's not an index. You have strings. So arr.add hello and arr.add world. Print those out and see. We have those words in there. If we want to remove them, we can't ask for the index. It's remove actually put in the item you want to remove to get the true there. Which leads itself to selection structures. Real quick before we do that, oh, well, I'll just work it in the selection structure. That'll work. Does that make sense for list? How to get a collection of things, and then we can just like Python, we use square brackets to index the item we want off there. So let's change item 1, assign that the number 8. And it is mutable. We can change it. So that's when I set dot for quite a while before deciding on which syntax to show it. I thought that was easiest. It's just that keyword, the stuff you want is a comma separated list in curly braces. Dot invoke gives you an array list, which has the advantages of both arrays and lists, like the name implies, including these methods, add and remove, to easily get things in and out of. For a good starting point. And remove gives us true or false. So the next thing to look at is probably a selection structure. Which is straightforward. What's different, well, our keyword is still if, just like in Python, but things are space delimited, so we can't do if space and then our condition. So our condition does have to go in parentheses. And our symbols are a little bit different as well. So if I started writing this like X, I'll use this symbol. This is the wrong symbol, but I'm going to write it down here to make a point. X greater than Y. Do you notice any problem there? If you need a hint, look at that. Look at what's highlighted to indicate what line I'm typing on. Our greater than symbol is already used, right? Greater than symbol means something to Windows. So these get passed in as parameters. So instead of, well, I'll just go ahead and list them all out here. LT for less than, or -LE for less than or equal, -EQ for equal, GE for greater or equal, or GT for strictly greater than. I think that's smaller than, so I'll go ahead and run that. And then some curly braces to block the stuff off. So similar to what we saw in Python, but a little bit different. And when building them up, it'll behave essentially the same. If that's true, then write X is smaller. And a closing curly brace. And just like in Python, the if block can stand by itself. But a lot of times we have if else, so I'll go ahead and combine that in one thing here. Talk about that. Close the curly brace, and then else, then another curly brace, and we can write the other way. Y is smaller. So we see X is the smaller one, and we can go back in and edit those. It's like, whoops, maybe I didn't want to see the actual word X is smaller than I wanted to see the variable there and see what that value is. So push up and get back to it. And it's a really, really good idea to delete that last curly brace if you go back in to edit stuff. Because otherwise, PowerShell might think you're finished when you hit enter to like add another line or something. And scroll up here. And I didn't want X, I wanted to concatenate X in, which that is one of the nicest things about open type languages. Or sorry, not open type languages, about loosely typed languages. Just, do you see what I did to concatenate that there? Nothing special, right?
You just threw it all in the quotes.
Threw it right in there. With loosely typed languages, we can do that. The trade-off is we need an escape sequence if we actually want to type a $, which on PowerShell is tick $, the normal escape sequence. But your variables just go right into the quote marks. And we can see the value that was stored there. So like make one called place, that stores the value world. And then we can echo the line, the standard one, hello, place, and some exclamation marks. And it just goes right in there. You don't have to do anything special for concatenating it. If it's just a variable, arrays are a little bit different. We'll see that shortly, I guess, after a break. Or echo, I love this place. And so concatenation in loosely typed languages is really, really nice. You don't have to worry about breaking out your sentence. It's loosely typed, so we don't have multiple data types. Whatever is there, whatever the computer thinks it means to put that as a string will go right in there. So a couple more things to talk about, but it looks like it's probably a good time for a break, right? We've been at this a moment. Then we still need to go over loops and functions. We'll do that. And then we'll look at the thing that makes it easier. Does 10 minutes sound good for a break?
Sounds good.
So the clock here on this computer says 7:20, so we'll get back to it at 7:30.